This is the solution guide to your polyatomic ion nomenclature packet. I believe this was page 5. I do apologize. You're going to notice the formatting is somewhat off when I transferred this over from PowerPoint onto this program on my iPad, which I record on. It kind of screwed up, so like none of the subscripts are written as subscripts. They're just in the line of text. Sometimes a letter or a number got put in a weird place. You're just going to have to deal with it. All right, thanks. Here we go. Buckle up. Okay, in this first example, you're going to notice we definitely have a polyatomic because you see some atoms bonded together there. So anytime you have more than two elements, it's not binary. And so this is going to be a polyatomic. We're going to notice that we have cobalt. Cobalt is a transition metal, and so we need to indicate what cobalt's charge is. So if I put the cobalt up here, this thing, this NO3 is nitrate. That 3 is part of the formula. You'll understand or see there's an understood 1 there that goes to the nitrate. The 2 goes up to the cobalt. You need to check nitrate, make certain its charge jives, which it does. And so when you name this, this should be cobalt, Roman numeral 2, and this is nitrate. Okay, the other thing you need to be aware of, that Roman numeral 2, the only thing that Roman numeral 2 means is that the charge of cobalt is 2+. It doesn't mean there's 2 cobalt. It doesn't even mean there are 2 nitrates, even though in this case it does. The only thing that 2 represents is the positive oxidation state of the metal. Cobalt 2 nitrate. Okay, in this example, we have another polyatomic here. But notice it's bonded to a representative metal, so you don't have to do any unzipping or anything. We're just going to call it sodium, and then NO2 is nitrite. So that's sodium nitrate, and that's it. Okay, for this one, this got screwed up a bit. I'm just going to cross out this 2, and I'm going to put it over here to make it a little easier. All right, so let's take a look here. We do have a polyatomic, and we have a transition metal. So we need to determine what its charge is. So the PO3 is part of phosphate. This 3 belongs to it. This 2 out here goes to the copper. Okay, if you look at phosphate, its charge is 3-, so we're good to go. We don't have to alter anything. And so what I'm going to do is I'm just going to call this copper Roman numeral 2 phosphate. Okay, here's another example. You'll notice we have barium. Barium is representative, so I don't have to unzip anything. I'm just going to name it barium. And then that polyatomic is cyanide. CN is cyanide, so that's barium cyanide. Okay, here's another example of a representative metal bonded to a polyatomic, so we just name it. Al is aluminum. And then SO4 is sulfate. That is aluminum sulfate. You don't have to tell me any charges or anything. That's it, aluminum sulfate. Here is yet another representative one. You'll notice potassium is the metal. Potassium is always 1+, so you don't have to tell me. If this is just potassium chlorate. Hey, for this one, formatting screwed up again. I'm going to just cross out that 2 and put it up here by the O. Okay, and once again, I apologize. Formatting's off. Those numbers should be subscripts. So we have copper and we have acetate. Copper is a transition, so we need to tell what its charge is. So I'm going to put the copper there. The C2H3O2 comes up here. There's an understood 1 that goes up to the acetate. That is its charge. There is a 1 behind the acetate. This 2 doesn't move. It's part of the acetate formula. And so this is copper, and then Roman numeral 1, acetate. Copper 1 acetate. Okay, in this example, we have another representative metal, francium. It's at the bottom of the alkali metals. And so you just name this guy. You don't have to do anything special. So this is francium. And then this thing is called dichromate. So that's a polyatomic, the Cr2O7. So francium dichromate. Yeah, I don't know what's going on here. That's an L. That's for chlorine, so I'll just put it up there by it. Okay, NH4. That is a polyatomic cation, the only one you need to know. Its name is ammonium. It is always 1 plus. It is representative, so you just name it. Ammonium chloride. Okay, this one was a little tricky maybe if you're not used to them. Okay, so we have a polyatomic and we have a transition metal, so we need to determine what lead's charge is. The only way we can tell what it is by unzipping it. There's an understood 1 that goes here. That 4 doesn't move, it's part of the phosphate, so there's an understood 1 behind it. But the thing you might recognize, phosphate's charge is not 1 minus, it's 3 minus. That's why you have to have these things memorized. So if I had to triple this one, I have to triple them both. So lead's charge is 3 plus. And so when I name this, I want to name it lead, Roman numeral 3, phosphate. Lead 3 phosphate. Alright, in this example, you'll notice we have barium, which is representative, so I don't have to do anything, I just name it. Barium, and then the polyatomic is hydroxide, so barium hydroxide. There's another goofy formatting. I'm going to just cross out that O and put it up here. So you're going to notice that I have potassium, which is representative. So potassium, and then ClO is hypochlorite. It's a polyatomic. So potassium hypochlorite. Alright, in this one we have rhodium 2 chromate. And so rhodium is going to be RH. This 2 tells us that its charge is 2 plus in this instance. If you look at rhodium, it is a transition metal. Rhodium has an atomic number of 45, and so it looks like it has charges of 2, 3, or 4. In this case, it is 2. And so now I have to put chromate on here. Chromate is a polyatomic ion. It is CrO4, and its charge is 2 minus. Well, if I have 2 plus and 2 minus, they're equal, they're opposite, they cancel. So it's just RH CrO4, rhodium 2 chromate. Okay, lithium hydroxide. Lithium is representative, it is always 1 plus. Hydroxide is a polyatomic, that is 1 minus. Notice it's the only polyatomic that really ends with IDE. Usually IDE implies it's an element, like chloride, fluoride, bromide, all that stuff. Most often you're going to see polyatomics end with ate or ite. This one happens to end with ide, so you'll just have to remember it. 1 plus and 1 minus, equal and opposite, they cancel. LiOH is lithium hydroxide. Okay, sodium permanganate. Sodium is always 1 plus, it's representative. Permanganate is a polyatomic ion, it's MnO4, and it's 1 minus. Because they're equal and opposite, Na, MnO4, sodium permanganate. Okay, in this instance we have manganese 3 nitrate. Manganese is 3 plus in this instance. Nitrate is NO3, and it's a 1 minus. So when you write them down here, MnNO3, this 3 comes down here, and to prevent it from looking like 33, you've got to put the nitrate in parentheses. The 1 goes there, and so it's MnNO3, parentheses 3. That is manganese 3 nitrate. Okay, we have barium nitrite, and so barium is always 2 plus. Nitrite is NO2 with a 1 minus. And so we need to cross these. Here's barium, here is nitrite. The 2 comes down here, put it in parentheses. The 1 goes there, so barium nitrite is BaNO2, parentheses 2, barium nitrite. Okay, for this one, aluminum hypochlorite. Aluminum is always 3 plus. Hypochlorite is ClO with a 1 minus. So when you write it, AlClO, When this 3 comes down here, you can't just put the 3, because then it looks like chlorate. It's not chlorate, it's hypochlorite. So you must put it in parentheses. So it should be Al parentheses ClO close parentheses 3. That is aluminum hypochlorite. Okay, here we have potassium phosphate. Potassium is always 1 plus. Phosphate is PO4 with a 3 minus. When I cross them, this 3 comes down here. PO4, the 1 goes there. It's understood. So potassium phosphate is K3PO4. Potassium phosphate. Okay, we have copper 1 acetate. Copper 1 implies its charge is 1 plus. Acetate is this polyatomic ion, C2H3O2 with a 1 minus. Equal and opposite, Cu, C2H3O2, copper 1 acetate. Okay, the next one is ammonium bromide. Ammonium is NH4 with a 1 plus. Bromide is Br with a 1 minus. Because they are equal and opposite, NH4 Br, ammonium bromide. Okay, for this one, sodium carbonate. Sodium is always 1 plus. Carbonate is a polyatomic, it's CO3 and it's 2 minus. When you cross them, this 2 comes down here. CO3, 1 goes there. So sodium carbonate is Na2CO3, sodium carbonate. And finally, last but not least, we have lithium chlorite. Lithium is always 1 plus. Chlorite is ClO2 and it's a 1 minus. Because we have equal and opposite, they cancel. LiClO2, lithium chlorite.